Good evening. We're Miracle Workshop, and this is our team. These are our faculty instructors, Dave, Brenda, and Ricardo. In addition to that, we have two alumni advisors, Tim and Andy. Our client is Give Kids a World, a nonprofit organization in Central Florida aimed at providing kids with potentially life-threatening illnesses and their families a week-long, stressless, free vacation filled with housing and amenities and anything else they might need. This is their village, and this is Tom. He's a hand-mechanized puppet that sits atop a balcony in the Castle of Miracles, which holds events such as story time and meet and greets. Currently, Tom is no longer being used because to get to him, volunteers would have to climb up a rickety attic staircase, go around the top of a moving carousel, and then sit in the dark behind Tom and operate this professional puppet, all with almost no training. Thus, our design challenge is to take Tom and turn him into an audio animatronic figure to perform in pre-programmed shows such as story time and dance parties. Our client is asked to make Tom robust because maintenance is relatively low at Give Kids a World due to its high cost and the amount of time that it would take. They also asked us to make Tom easy to use, both for accessibility for their volunteers and ease of operations because of the large age range and ability range. Finally, they wanted Tom to be engaging and seemingly interactive for their guests. Given all this, we've decided that our most important metrics are our client requirements so that we meet all the needs of Give Kids a World and we provide a show that resonates with their target audience, technology so that our animatronic is robust, vetted, and reliable, and quality assurance so that we reduce maintenance and provide documentation for any maintenance that is necessary so that Tom can run for years to come. In order to understand how to make Tom and his show, we've divided our target demographic into two main camps. Those who are working with Tom, such as volunteers, maintenance staff, and Give Kids staff, and those who are interacting with or watching Tom, such as Wish Kids age 5 to 12, their siblings age 3 to 17, and of course their parents. Now, Wish Kids and siblings are both dealing with these illnesses together, but they're facing opposite sides of the same coin, and thus their needs are different, and we have to consider these two groups separately. To talk about how we're making Tom, here's Alex.
Thank you, Reza. To begin, how I am able to do this is I am working with industry experts Tim Eck, who is the animation systems team lead at Disney, and Andy Hosmer, who is the senior model maker at Apple, as well as the designer of Quasi while he was here at the ETC. I have weekly meetings with them where they are able to critique my design, but also offer help and guidance in my design process. Their feedback has been integral to us being able to deliver this installation in such a short amount of time. So to begin with mechanical design, I started with reverse engineering Tom. This first image on the left is a 3D model of Tom that was generated using 2D photos and stitching them together in a program called Recap. This mesh allows me to design around Tom's existing foam skin and his posture. The middle photo represents when we started to deconstruct him, so we could see how the inside of his foam looks like and also how that mechanism controls him. I was able to model that in SolidWorks to be able to discover what parts and aspects of the design could we reuse for the new mechanism in Tom. So pre-visualization is a huge tool that we use to be able to predict where to put certain joints in the body of Tom. Something that's really important to know about this project is that we are not just building a robot, but rather we are bringing a character to life. This is why it is so important for Tom to be as anatomically correct as possible. I had Niharika and Maya place pivots at certain points to represent the different functions. This is an example of how we did head tilt. At first, due to the size constraint that is in his neck, we placed head tilt at the middle of his chest. As seen in the first video, that looks more like a swaying action. So then I asked Niharika to place it at the bottom of his neck. If you look at the video, it has a more limited range of motion, but it does appear to be more lifelike. We then compared this to a human model and determined that it was indeed true that head tilt does occur at the bottom of the neck. So lastly, I am able to use all of these tools to finally design Tom. I start with pen and paper and create sketches and look up hardware to be able to implement into SolidWorks and create these 3D CAD files. And then also I use that 3D mesh of Tom to place the mechanism inside to make sure that it is sized correctly and it fits with his existing character and posture. The next steps are to finish the design by next week and to have these parts fabricated. We are going through a vendor called Protolabs, which has a 3-day turnaround time and has the tolerance that we need to be able to fabricate and assemble Tom in the amount of time that we have left for this project. Next to talk about the animation pipeline is Naharika.
By using the 3D model, we are replicating the mechanical design by placing the joints at the position of the servos and the pivots. Our goal is then to use this model not only for pre-visualization, but also for creating animations. This is a replication of the mouth mechanism. The arrow is pointing to the parent joint, which is at the exact position as the servo. This will then rotate and control the mouth movement through the connecting pivots. After we have completely replicated the head and the torso mechanisms, we will use the model to create animations, which will then be translated to the animatronic using a 3D converter software. This software has been provided to us by Weigel and will allow us to convert the joint data to the servo data. Apart from this, we have also created animation prototypes to imagine Tom's interactions. This has also helped us in making decisions regarding the speed and the movements that will make Tom look more natural rather than like a robot. So this is a prototype of one of Tom's interactions that he will likely have at Give Kids the World. So when Tom says,
"Hey kids, what did the Pacific Ocean say to the Atlantic Ocean?"
Then, after a response from the volunteers or the kids, he will respond back saying,
"Nothing. It just waved."
These will then be translated to the animatronic to make Tom come alive. Now, Atul will talk more about the programming pipeline.
Thank you, Niharika. So this was what we thought initially would happen. We'll have a computer who's going to send some commands to the robot standing here, and it's going to move. But of course, it wasn't that easy. This is what we finally ended up with. We had a computer send signals to a show controller, which in turn controlled another device called a servo controller, which finally controlled the servos. Our show control system was heavily influenced by the fact that Weigel had graciously offered to donate certain equipment. We are using 3 different boxes from Weigel as of now, one for lightning, one for show, and another for servo. The main show controller stores the shows. By show, I mean any combination of lights, audio, or servo movements. The lightning controller takes some inputs from the show controller and converts it into a language that the lights understand, similar to the ones above us. The servo controllers does the same, but for the servo motors. Now, Josh will talk more about how all of these work together. Yeah.
So, this show control equipment does not just exist in a vacuum. It's part of our greater show control network. This also includes speakers, lights, and a camera showing the operator Tom's point of view. It all comes together when a volunteer presses a button on our touchscreen. This then sends a signal to our show controller to play back a specific animation. The show controller then sends those animations out to the various components such as the servo controller, the lighting controller, speakers, and then those play back their specific animations, giving us a complete show experience. It goes without saying that safety is an incredibly important part of our project. We want Tom to be safe for the volunteers that operate him and also safe for the staff that maintains him. To do this, we will be conforming as closely as possible to industry standards to make sure that Tom will be extremely safe. These standards include UL 508A, which is the Industrial Control Panel Fabrication Standard, NEMA, which is the National Electrical Manufacturers Association, and NFPA 70, which is the National Electric Code. In addition to safety, reliability is extremely important. We want to make sure that Tom is here for years to come to entertain kids that Give Kids the World. We are making sure that he is reliable by using products that are known to our industry experts to be extremely well made and reliable, choosing components that are made by companies that offer long-term parts and support, and selecting hardware that has what's called an MTF, or mean time to failure, so we know exactly how long they'll last. To reiterate our whole pipeline, it all starts with our mechanical design. That then influences our rig in Maya, and then we can animate Tom there. Those animations then go through our converter software, which gives us data that our conductor software, which is how we program our show controller, can understand. That data goes into our show controller, and then eventually out to Tom. Now to walk you through our live demo, here's Dustin.
Thank you, Josh. We're really excited about this live demo in that it shows off our pipeline from beginning to finish, from the touch screen to Alex's design. So a volunteer will touch an action on the touchscreen.
Hey kids, what did the Pacific Ocean say to the Atlantic Ocean?
I don't know, Tom.
Nothing. It just waved.
So these are the types of superficial interactions that we're aiming for. We also have another one for story time.
I love a good story. What are we reading this week?
How about The Cat in the Hat?
Oh boy, I love that one. Will you read it to my friends and me?
Of course. So the client has asked us to create an engaging and interactive show. Come to find out that creating an interactive and engaging show is very difficult. So we've been working with professional actor Tim Hartman. The dialogue that you just heard was just some scratch audio to develop Tom's character profile, and so he fits within Give Kids the World. We've been communicating with them to discover what sorts of experiences that are going to work best in their environment. We asked them through a list of 5 choices to choose 2 so we could deliver within scope. They chose 4. They put 3 of them within 1 experience. They've asked us to create these experiences to be versatile. So within this one show, it'll have a dance party, a story time, and a good night experience which interacts with an existing animatronic there in the village. These experiences are versatile in that they can be changed, modulated, or cut depending on the needs of the village. Our scheduling becomes very important so we can deliver on time. We are working very quickly to make sure that our design is finalized by next week so all of our parts can be ordered and then assembled on time so we can have adequate time to program adequately. We're also working on developing our story content so that we can then play test and make sure that all of our content lands. If we don't meet our time to order all of our parts and to receive them, we've been working with faculty to come up with backup plans, which may include pushing back our installation until after finals. Our concerns at this point are to have time for documentation. Handoff is very important to make sure that we give them adequate materials so they can maintain Tom for years to come. We also want to make sure that our design is vetted, and so that Tom will last for a long period of time, and make sure that it's vetted rather quickly so we can have time to get those aforementioned parts. We also need to make sure that the story is finished and all of the content is finished so we can get the voice recording done and so the programming can be implemented. And then we're also looking at potential overscoping, including the number of functions that Tom has. We're currently looking at potentially eliminating some so we can deliver to our client on time. Once again, thank you to all of our sponsors, all of the people that have helped us out. We've had generous donations from Ultramotion, iTech, Weigel. Thanks to all the people in this room that have helped make this happen up to this point, and Tim Eck and Andy Hosmer. Once again, we are Miracle Workshop. We're aiming to revitalize an experience at Give Kids the World by creating an easy-to-use animatronic. We're open to questions at this time. Thank you. Yes.
Are you guys planning to have, so like since you're, if like your scope is too big, you're going to cut down, are you planning to allow anybody at Give Kids the World the ability to add on new video or anything like that?
Yeah, the question was in terms of integrating our programming. And so we're working on focusing our scope on one show at this point, but we're also iterating on a second show, which we would ideally provide some audio in the programming so then someone can implement it further down the line.
What are you most worried about at this point?
Our biggest concern right now is getting parts in on time so we have time for assembly and then time to program Tom.
How will you keep this simple and maintainable so that if one component breaks, Give Kids the World can figure out which one that is?
The question is over maintainability. I don't know.
I can take that. Each of the component is divided, and so first of all, the design, it's modular enough so that if one of the servo breaks, it will be quite visible, so we know, okay, we know this is the server which broke. Apart from that, we'll have a whole documentation which will go from step one, which is opening the back of Tom, all the way to replacing it.
Part of our handoff is to include comprehensive material so they can maintain Tom. And we're looking at creating video documentation so that they can have easy reference to make that possible. Yes, Axel?
To clarify, the animations and voiceover you're working on now are over the show that you are creating, not existing content given to you, correct?
Correct. The question was over show content. Tom has not been operated in about 5 years due to them not having a professional performer or content to run Tom, so we are working on creating the content for him. Anyone else? Thank you very much.